Here we are, Unit 6, the halfway marker of the curriculum. Unit 6 is all about circles, so this video is going to talk about all the basic definitions of circles. So I'll admit it'll be a little more boring than the other videos, because all those other videos were very exciting. But it's really important to get down this basic vocabulary in order to succeed later on in the chapter. So, let's start with a circle. A circle, I'm sure you know what a circle is, but the technical definition of a circle is the set of all points in a plane that are a given distance from one point, which is the center of the circle. So let's see what that means. We have one point, let's say right here, and let's say the distance between these 2 points is, 1 inch. Then a circle would be every single point that was exactly 1 inch from that original point, which is called the center of the circle. Now I'm just drawing a few of them right now, but if I drew an infinite amount of them, it would become a circle. So let's X that out. No, cancel. Don't want to do that. Sorry. A circle is a set of all points in a plane at a given distance from a point, and that point is called the center. The distance from the center to each of the points on the circle is called the radius, and I'm sure you're familiar with that word as well. Congruent circles are exactly what they sound like. Two or more circles that have the same radius, which means that if they have the same radius, they have to be the same size circles. So this picture over here, the CDs, is a good example of congruent circles. Since we're assuming that all those CDs are the same size, that would be a real-life example of congruent circles. Similar word would be concentric circles. Well, congruent circles are circles that are the same size. Concentric circles, focus on this word right here, are circles that have the same center. So, you can think of all of these circles that make up the target as concentric. Two or more, in this case many, circles that share the same center. A chord is, well, if you look on the left, we have A, B, D, C, E, F, H, G, and I, J all drawn, and what they all have in common is that they're all line segments in which their endpoints are on the circle. And if you look on the right side, those non-examples, none of those segments, P, Q, R, S, U, V, W, T, whatever, none of them are segments that have both of their endpoints on the circle. So, that would be the definition of a chord, which is indicated right here in this picture. A line segment whose endpoints lie in the circle. And you could sort of, when I hear the word chord, I think of a guitar. And if I drew like a bunch of chords, bear with me for a second, it would look like the part of a guitar where the strings go over that open piece. Now sorry, I'm not that into music. I don't know the technical term, but imagine like a guitar like that. Just coming up. Alright? Diameter is, you would probably think of it as two radiuses, but the technical definition is that it's a special type of chord that goes through the center of the circle. Or in other words, it's the biggest chord possible. So if you look at A, B, C, D, and E, F on the picture on the left, those are all diameters. So unless it's a chord that goes through the center of the circle, then it's not a diameter. So here's another example of a diameter. Goes through the center of the circle, a chord. Alright, and you can also think of it as two radii, which form a line segment. And then tangent. Tangent is a line segment that hits the circle at exactly 1 point. So if you look at A, B, F, E, and C, D on the left, all those points, what they have in common are that they have exactly 1 point on the circle. PQ on the right, that's called a secant, which is like a chord, but it's a line, not a line segment. So if you have a line that goes through the circle and hits it at more than 1 point, or at 2 points, or else it wouldn't be a line, it would be secant. But if it hits the circle at exactly 1 point, it's called tangent. And here's another example of a tangent line. And again, it's a line that touches a circle at exactly 1 point. Now, again, definition right there, it's a line that touches a circle at 1 point. We say that line T is a point of tangency. So whenever, that's one way you can refer to a tangent line as a point of tangency if you have a line that's hitting a circle at one point. One special thing about a point of tangency is that a tangent is to a circle is perpendicular to the radius drawn to the point of tangency. So it's kind of, if you just look at where radius OT intersects the tangent line T, it looks like it's being intersected at a 90-degree angle. And I know that's not a very good proof, but try to think of, let's say that the radius OT and the tangent line didn't form a 90-degree angle. So it kind of looked like this. Well, then notice that it's no longer a tangent line. It's hitting a circle at 2 points. Or if we made that angle look like this, again, that line is hitting the circle at 2 points. So if the line hit the circle at exactly 1 point, then you're going to get a 90-degree angle between the point of tangency and the radius. Good to know, right? Good stuff. Now, a tangent segment is a line segment that lies on the tangent line with one endpoint on the point of tangency. So, if we had a circle and we make our point of tangency right here and then some other point outside the line, this right here, pretend that's straight, would be a tangent segment. And there's one special thing about tangent segments, in that if you have two tangent segments, if you have two tangent segments to a circle from the same point outside the circle, then those tangent segments are congruent. So let's say that we started by drawing this point N right here, and then we drew segment AN, and then segment NG, then we know that AN is congruent to NG, because both those segments are tangent to the circle, and they both have the endpoint N. Tangent circles are two circles that are tangent to the same line at the same point. So, two circles are considered externally tangent if both circles are tangent at the same point and they're both outside of each other. And if one circle is inside the other circle, or in other words, both of the centers of the circle are in both circles. So notice here on the right, both center of the circles are inside both of the circles, then it's called internally tangent. But if each center of the circle is in its own circle and not in any other one, then it's called externally tangent. So, let's apply that stuff that we just learned to try these two examples. So, I'm going to talk about a couple things that we really haven't learned yet, but it'll come up in the next video. And those are things called arcs and central angles. So, this 220 right here is saying that from A, this arc from A to G is 220 degrees of the entire circle. And we know that an entire circle is going to be 360 degrees. So that means that since 140 plus 220 is 360, and let me go a different color, that this arc from A to G, but going the short way around the circle, is going to be 140 degrees. Now, that means that this central angle, ANG, right here, is also going to be 140 degrees. So now we have a quadrilateral, TANG, and we know that angle TAN right here is going to be 90 degrees because it's formed by a tangent line and a radius. And we also know that TGN is going to be 90 degrees because it's formed by a tangent segment and a radius. So, if we know that all four of the angles of quadrilateral TA and G add up to 360, and we know that the central angle is 140, and we have two 90-degree angles, that's not what I meant to do, then that means that this angle T right here has to be 40 degrees in order for all four angles of the quadrilateral to add up to 360. So that would be our answer. So again, you have to know something that we really haven't learned yet, that central angles are the same measure of the arcs that they intercept, and that tangent segments form 90-degree angles with radii. And also some information from the last unit about quadrilaterals. one more problem that we can do with all the information that we've learned so far is this one right here. So let's say we had 3 circles, circle A, B, and C, and you name a circle by its center. So, and the diameter of circle A is 10. So that means that this segment AX has to be 5, because if the diameter is 10, that's made up of 2 radii, so the radius has to be half of that. So if you ever know a diameter, you can find out the radius by just cutting that number in half. And vice versa. If you know the radius, you can figure out the diameter by doubling it. It also says that the diameter of circle B is 20. So that means that this segment, AB, the radius, has to be 10. Which would mean that this segment, XB, has to be 5 in order for AB to add up to 10. We also know that the diameter of circle C is 14 inches. So that means that YC, the radius of circle C, has to be half of 14, has to be 7. So that also means that BY would have to be 3 in order for radius BC of the big circle B to still be 10. So BY is 3. So let's answer our questions, and I think we've done that already. Find XB. Well, if we look at our picture, we know that XB is 5. And find BY. Well, we know that BY is 3. And I think that's about it. Let's see. Yep, that's about it. So thank you for watching, and have a good one.